Hello everyone, I welcome you all to this 30 days masterclass series. Today is day 3. I welcome all the participants. Yes, welcome all the participants. Welcome Stravani, yeah, Ray, TS family, Vicky, Kausalya, Prakash, Rupa. Warm welcome participants. Let's get into the topic. Vikash Kumar, how can I find last 2 days video class? You just go to YouTube, search pantechelearning, you will get a last 2 days class. Mr. Vikash. Yes. Very good evening, Mr. Sridhar. Certificate will be provided after 30 days. Yes, certificate will be provided after 30 days. Yes. Am I audible? Dear participants, can you confirm? Am I audible? Dear participants, can you confirm? Am I audible? Very good evening. Attendance link will be provided at 8:45 p.m. So you don't worry, don't rush up. Certificate will be provided at the after 30 days. After 30 days. So we will guide you how to get a certificate. Dear participants, can you please confirm? Am I audible? Yes. Thank you, participants. Thanks for your comment. Yes, thank you so much. Thank you for your reply. Right. So this is Malaypan from pantechelearning Private Limited. My research area is about advanced power electronics, renewable energy, special electrical machines, electric vehicle, and power supply design. So these are all my research area. So you can post your queries related to this area. I am here for next 28 days to help you to develop a complete EV model in the simulation as well as in the hardware. Right. So I take my number. I will share you my contact information at the end of the session. So please try to engage with the entire class. Right. So just try to engage with the entire class. Certificate, Mr. Sivaraman, you just follow the WhatsApp group. There you may get a link to get a internship. Right. So about Pantech is basically educational equipments manufacturing company. So there you can get laboratory equipments for ECE, EEE, computer science and IT. And our vision is to help the people to learn the technology in easy way. So far we have trained about 20 lakh students. Right. And announcement. The attendance form will be provided at 8:40 p.m. So please don't rush up. You will get attendance link and it will be pinned in the live chat box. So don't rush up. You don't forget to submit your attendance also. Don't forget to submit your attendance. Right? Because the 25 days attendance is mandatory to get a certificate. So then only you will get then only you are eligible to get a certificate. Right? Right. So today we are going to calculate the force again with the that is the extension of the day 2 session. We will discuss one by one. So try to engage with the entire session. Right. So are you ready to learn the concepts? If you are ready, please type in the comment box ready to learn. If you are ready, please comment in the comment box ready to learn. If you are ready, please comment in the comment box ready to learn. Yes. So day 2 PPT will be shared after this live. Certificate we will provide you by end of the series, not today. End of the series we will provide you. Yes. Yes, thank you, Mr. Shivraj. Thank you, Mr. Krishna, Kausalya. Thank you so much. Thank you for your valuable reply. So now let's start the discussion and just continue to the yesterday topic. See, whenever you want to calculate the total motor power, exact required motor power. So of course you should know all the tractive forces, right? So what are all the forces which will be available on the vehicle? So the first one is that rolling resistance, aerodynamic drag force, hill climbing force, and acceleration force. So these are all the forces which we have to calculate, right? Which we have to calculate. So now just to recap the formula, right? So the total tractive force Ft is equal to total mu rolling resistance force, aerodynamic drag force, hill climbing force, linear acceleration force, as well as that angular acceleration force. So these are all the total tractive force. So if you multiply these all the forces with the velocity, then you may get a total tractive power. You can get a total tractive power, right? So let us take the same example. So we can calculate the total power for the 40 kilometer power required to climb the 40 kilometer. Of course we need 2.5 kilowatt motor power, right? So 2.5 kilowatt motor power if you apply the formula. So now if you include the hill climbing force, then what it will happen? If you include the hill climbing force, what it will happen? So now let us check one by one. So here I will show you the calculations, how you can develop the calculator, right? Just a second, I will show you the calculator. So now we are going to analyze how the power may increase when you slightly introduce the grade angle. Right? So let us take the same value. So let us compare the same dimensions of the vehicle, and whenever your vehicle cross that grade angle, like if it is upgraded or downgrade, not a problem at all. But when the vehicle is in the upgrade, then you need more motor power, right? So you need more motor power. So how you can calculate that power? So here the angle should be converted into the radian, right? So to get the radians, you just convert with the particular degree and multiplied by pi by 180, so that you can get a radians. That is called theta, right? So the hill climbing force, if you have not compared, then without hill climbing, then the motor power requirement is about only 2.5 kilowatt. Suppose if you are introducing 10-degree grade angle, then you may require the higher than that value. So you may require the higher than that value. See here. So this is the total exact motor power. So you have to calculate all the total forces. Yes. So M into G, and I just add this value. Yeah, I'm just adding. See here, about 21.4 kilowatt motor power may require. 21.4 motor power may require, right? So this is the power variation. See, without hill climbing, you can run the vehicle very less power. But if you want to add the grade angle, then you can check that power variations. See here, the huge power variation may require. Then you no need to calculate the linear acceleration, because it's going to be like 10% of the it's going to be just 10% of the entire power requirement. So in that case, that power will lies within this limit itself, because the hill climbing force is again 10 times of the actual power requirement, right? So it's going to be 10 times of the actual power requirement. So in that case, the linear power will be available within that power will be resolved within this power range itself. So this is a simple difference I want to share with you. So from this one, we are trying to calculate how much time will take to reach the maximum power, and here what is a torque, and then what is a power when you get a motor, when you get a exact mechanical output from the electric motor. So since actually the main biggest advantages from mechanical like IC engine with the electrical engine. So when in the IC engines, so you cannot control torque or power simultaneously, whereas here you can operate with the higher you can get a controlled torque as well as the controlled power from the motor. So that is called what? Speed. So you can control it by implementing different type of algorithms. I will tell you with the simple graph. Right? If you have any questions, you please comment. I will try to give you the answers. If you have any questions about the calculator, you just comment me. I will try to give you the answers. Yes. So Amrita, what is your query? I couldn't. Just a second. So the solver error, model error denotes that you have not included the f of x solver. So just include that solver into your any ground plane. In the Simscape workspace, you should include the solver, right? So now let us take that simple case study. So from this one you can easily understand the power calculations. Now, so from this from the power variation, the same may happen when the load, when the vehicle is in the hill climbing conditions, when the vehicle is fully loaded to the unloaded conditions, right? So these are all the huge power variation may happen when you drive your vehicle in the road, right? So how you can consider those conditions. So here, if you take that extremist conditions, which means that, so if you are claiming 10 percentage, if you are claiming that 100% motor, for example, 1000 kg loaded at a certain 40 km per hour. So in that case, what you have to do? So you have to add 20% extra. What you have to do? You have to add 20% extra load. So in that case, 1200 is the total load capacity of your vehicle. At the same time, the gradients. So for the gradients also you should increase the higher percentage. Then only your vehicle will get a higher stability. Right? So here, if you take that, because the vehicle is not going to be at a constant speed, so always there will be a change when change depends your driver input as well as the road conditions, right? So now we are in the position to calculate the dynamic speed of the vehicle, right? So here there are some limiting factors are there. So which means that total weight of the vehicle and then motor power demand of the vehicle. So these are the major limiting factors. And additional limiting factors nothing but see here, irrespective of the torque power than the power applied in the train to the wheel. So that is one limiting factor. Same way, so that depends the road type. So actually if you apply the power and then the wheel started to rotate, but due to the road condition the wheel will get slip due to it's a soft soil or icy or whatever it is, right? And the third one is that the vehicle the tire will get spin around it because the adhesive capacity may be very less. So these are all the limiting factors. So while you design your vehicle, you should take all these factors into your consideration. So now let us take this one. See here, if you want to run the vehicle, then the tire should be in the positive slip. Whereas if you want to apply the brake, then the input power should be less, and then the adhesive capacity should be high. So in that case, the braking may apply from the first, from the first image, like if you want to apply a push force, if you want to apply a push force from the to travel to move the vehicle from one position to another position, then you should take a, you should then only the vehicle will get move, otherwise the vehicle will not get move. Same way, while the vehicle is in the running condition, if the push force is very less, then the opposite forces will get increased. So in that situation, the vehicle will move into the braking mode. So all these things we will explore in the simulation. We from the yesterday simulation itself, we can analyze those behaviors. For example, if you take that same simulation, for example, yesterday we kept some basic value called, like this is the some typical value, right? So let us take this one. It's about 350 kilogram will be the total value, right? So this is the 250, this is the 350 value. So let us take 350 value. So now let us try to solve this one. See, the gradient is in the negative gradient, so the speed will be in the positive. Speed will be in the positive. So let us assume this is the 40 km per hour. Suppose if you increase the vehicle weight, right? If you increase the vehicle weight instead of 40 kilo, instead of 350 kilogram, 2000 kg. So let us check what will happen. So definitely, whether if you increase the weight in if you put the vehicle in the down gradient, then what will happen? Can you just comment me? Can you just comment? If you increase the vehicle weight and if you put the vehicle in the positive negative gradient, what it will happen? Can you comment whether the speed will be increased or decreased? Can you say yes or no? Can you say yes or no? The speed will get increased or decreased. So earlier it was the 40 km per hour. Now I have increased the speed of vehicle weight. So now see here, I have earlier case it was 40 km per hour, right? So now the speed has been doubled, about 70 km per hour, right? So because the vehicle weight not a decrease, it's increase. Yes, exactly, Mr. Darshini. That's the answer. So the speed will get increased because the vehicle weight may, due to the vehicle weight increase, right? The same way, so here, so in that case we need a more motor power to operate your vehicle. So now let's come to the point. So here if you want to drive a motor, so this should be positive, then the motor will get forward directions. Here if this should be 0, then the motor braking will be get applied, then the motor will comes to the standstill position. So like that we can understand the dynamics of the behavior. So from this calculation, see here, at the initial stage the motor torque and then speed will be the 0, right? So this is the 0.0 position. So now you have you have started your vehicle. Now you have started your vehicle. What it will happen? See here, the speed will be 0 and it will try to increase maximum from 0 to maximum, right? Just a second. So the speed will get increased from 0 to maximum. So in that situation, what it will happen? See, whenever the speed is very low, but the torque should be high. So that is the motor responsibility. So till the maximum torque should deliver by the motor till its critical speed. Do you know what is critical speed? So the critical speed nothing but it's a rated speed with the rated condition, loading conditions. That is the critical speed. Alright. So here this region called as a constant torque region. So during this region you can handle the maximum load. You can handle the maximum load, but the speed will be less. Right? So after the critical speed, so here the speed you can increase at certain stage and not more than that value, but of course you can go more than 20% of the rated speed, but the loading capacity may get reduced. Right? So from this one, and so from this graph we can easily understand. So here the main takeaway is that the motor has a critical capacity. Critical speed behavior. Till that critical speed behavior, the motor will deliver maximum torque and maximum speed at the maximum speed. So here the safe operating region is that. So here you can handle both the value, like you can operate the load and you can operate the speed. But if you need to operate more speed with more load with less speed, then this is the region. So that's why your vehicle is in very less speed when you drive the vehicle. If you take IC engine, that the vehicle will handle the more weight when it is in the lesser speed. Like first gear, second gear, third gear, it can handle maximum load. Right? So now here we are I am trying to give you some example, so which means that this is some motor typical data. This is the motor typical data, vehicle typical data. So the weight of the vehicle, drag coefficient, rolling resistance, and then area. So here the gear ratio, it's about 11, and then vehicle wheel is about 0.3 meter, and gear efficiency is 95%. So now for this dimensions, the motor power is 102 kilowatt and then 7000 rpm. For this motor we can take a 140 Newton meter. So this data we have to get it from the data sheet. So now at what range the motor can deliver at 140 Newton meter, because this is the rated torque by the motor. So here if you apply a throttle from 0 to maximum, so slowly the vehicle will get move, right? So the graph will get linearly increased. So this is the radius. So gradually it will get increased. See here. So for example, so this region you may get a 140 Newton meter. This region you can get a 140 Newton meter. At this moment you can get a 140 Newton meter. And so let us assume this is the critical speed. So like 732.66 is the critical speed, right? So radian per second, nothing but it's angular velocity. So we have to tell that radian per second. Right? So let us assume this is the critical speed. Till that area, the motor will deliver 140 Newton meter. Once if the motor increased that beyond this limit, then the torque will get reduced. So the advantages of the electrical motor by implementing FOC algorithm or vector control algorithm or direct torque control algorithm, you can program the torque as well as the speed. Right? This is the main takeaway from this slide. And same way, see here, what is the maximum velocity of the vehicle? So from that one, so here the motor critical speed is 732.66 radian per second. Same way, so here the motor is generating the speed rotation. That rotation has been converted to the vehicle, right? So now what is the critical velocity of the vehicle? So from this one at this range, so here 140, and then just apply the simple value, then you may get this value. So 19.8 meter per second. So this is the critical velocity of the vehicle. So up to this, whenever you drive this range, so from this you can apply the you can convert into kilometer per hour. So from this value you can convert to kilometer per hour. Simply just apply the value and then calculate it. So till that value you can get an exact full load torque. So there you can get you can operate the vehicle in very safe first zone with the speed and then torque. I hope you understood. If you have any questions, you can ask me. I'll try to give you the answers. If you have any questions, you please ask me. I will try to give you the answers. If you have any questions, you please try to give me. I will try to give you the answers. Right? So from this we can calculate the kilometer per hour for the any motor. We can calculate the maximum kilometer per hour and maximum torque deliverability by the motor. Maximum torque deliverability by the motor. Yes. How can be the slip in the DC motor if it can appear in the AC motor? See here, the slip will be applicable for all the motors. Slip will be applicable for all the motors. Can we get this Excel calculator on our WhatsApp group? No, Mr. Anuj, you should download this calculator from the internship portal. Thank you, Mr. Definition of critical velocity. The critical velocity nothing but so the velocity at maximum velocity the motor can deliver maximum the rated torque. That is a critical velocity. When load will increase and decrease continuous, what will happen? See here, for that you should consider the three different range. In the previous example, I told you that the vehicle kept in the down gradient. During the down gradient, if you increase the vehicle weight, of course the speed will get increased. Yes, Mr. Ian Raj. Does motor and weight of vehicle have any proportional values? Exactly. Motor, if you increase the vehicle weight, of course you need a high motor power. Define motor slip. So which means that here we are telling the speed generated by the motor and speed transferred to the tire. So that is the difference between these two values called the slip. How to calculate the gear ratio? See here, here we have to choose the gear ratio. Either do you want 1 or 2 or 10 or 5 or 11 or 20, whatever you want. Velocity corresponding to the critical speed is critical velocity. Which motor is used in EV? See, there are different type of motors for different applications. For two-wheeler, we can go with PMDC and then BLDC. For three-wheeler, still we can use the BLDC also. For other than three-wheeler, we have to use other than two-wheeler and three-wheeler, we have to use the permanent magnet synchronous motor or switch reluctance motor or AC motor, induction motor. Thank you, participants. So let's move to the next one. So I will show you yes, I will show you the MATLAB demo. Just a second. Let us take basic functionality. See here, with MATLAB you can get you can do any kind of logical operations. So to understand the logical operations, see here that there are all the mathematical functions are there. So you just click this button, you may get a add block. You can do the add block, and you can take a bits operation called gates, logic gates, all the logic gates. For different motor, see the motor power only the constant, so you can all the calculations are remain same for all the motors. So here we discussed only the vehicle dynamics, not a motor dynamic. Right, so I will show you some simple logical functions how you can develop, where you can start. Right, so see here, just take a bits operation. Let us take a AND logical operator. So now I will tell you how to generate how to compare two signals. See here, I'm just going to take two signals. So one is that square wave. See here, I'm just taking the square wave. See here, for the square wave, can you just tell me what are the parameters? So if you take this one, see here, this is the, let us assume this is the square wave, right? So let us assume this is the square wave. See here, so let us take, this is the starting point at t is equal to 0, right? This is the starting point, t is equal to 0, t is equal to 0, and this is the again this is the at this moment t is equal to 0, so this is called t on time, and this is the t off time, right? So now the entire cycle, full cycle is called a period. Entire full cycle is called a period, and this we can call it as a on time, and this we can call it as a off time, right? So just apply this value. So amplitude here, the maximum value is the amplitude. Let us keep this one. Period, let us take, this is the 10 seconds. So let us keep 1 second is the period, and pulse width. So here this is the on time. So here the people will tell us as it is like a percentage of the period. So if you keep the 50, nothing but 50% exactly on time of the 1.5 seconds, and remaining 0.5 seconds it will be 0, right? So if you apply this one, then you may get easily answer that one. So take a scope block, just take a scope block, just take this scope block. So now you may get the value of the square function, right? So this is the simple, this is simple square wave generator. So now if you take another waveform, see, take one more waveform. So for the same 50%, now I am going to have a 2 period. So that period is about 2 seconds. So just take this value. So we can modify the parameter, scope parameter, by selecting this control settings parameter function, and here you can just take 2 scope with a different level. Just to take 2 scope with a different level, you can change the layout also, right? So now if you try to run this simulation, just try to run this simulation. See here, this is the one wave and this is the second wave, right? So this waveform rotating at 1 second, and this waveform rotating at 2 seconds. So now if we compare these two signals, so if you apply the logic, digital logics, AND gate, so here we can get another waveform. So here we can get another waveform, right? See here, if you increase the value, just change the layout, See here, the idea is whenever the AND gate functionality is, whenever the two signals are high, then only that AND gate output will be high, right? So we are applying 2 input and we are getting the output. So this is the logic, some simple digital logic we are getting, and we can create at any kind of similar kind of digital logics. So we can create any kind of digital logics. I hope you understood. If you have any questions, you can ask me. I hope you understood. If you have any questions, you please ask me. This is a simple digital logic. This is the signal 1 and this is the signal 2, and we are applying to the gate AND gate signal, AND gate function. Yes. So here, yes. So here the logic will generate a different function. I mean, based on the AND logic, you can get output. Right. Same way, you can also create and you can share the output in the community blog. I mean, in our EV community, that I will share you in the WhatsApp group. Right. So if you have any questions, you please comment. If you have any questions, you please comment. Do you have any questions? You please comment, and we will move to the next example. Shall we move to the next example? Can you just comment? Dear participants, shall we move to the next example? Oh, voice break. Okay, just a second. Yeah, see here, thank you, Mr. Darshini. I will repeat. So now I think yes, so now it is resolved. So this is the pulse 1. So here this pulse rotating at 1 seconds with the 50% duty cycle. Same way, this is the pulse 2 for 2 seconds period, and again the 50% duty cycle, right? And this 2 pulse, simply just connect this one like this. You just connect like this. I will show you. So just drag this button and connect here. Same way, just drag this button and connect here. And so now you here at this moment, at this point, you just take a right click and then drag it. Just right click, select the line, just right click wherever you want, and then you can connect here. Right? So now you can get, if you run this one, then you may get a different value. You can get output. Same way, yeah. So this is the pulse 1 input pulse, and then this is output pulse. This is the gate output. I mean, AND gate output. So simple logic which we are discussing, we can use any kind of gates, not a problem at all. So here, if you take if you select this one, say all the gates are available. So all the gates are available. I am just sharing you this experiment for the purpose of for your applications. When you need to generate a customized signals, then you can use this kind of signals, right? So now, of course, in electric vehicle, we are going to utilize electrical motor. So that electrical motor controlled by the pulse width modulation. Do you have any idea about the pulse width modulation? Do you have any idea about the pulse width modulation? So the pulse width modulation, nothing but it's a controllable value. See here, we can adjust the pulse width. This is the simple PWM signal. So this signal, by changing the logic, this pulse width may adjust it, right? So this pulse width D is directly proportional to your motor speed. The pulse width D is directly proportional to your motor speed. So now we have to adjust the pulse width. How we can adjust the pulse width and all, I will tell you one by one. So just engage the class. So now I am going to add few more signals. just to take a sine pulse with sine wave. Yes. So this is the sine wave, right? In the sine wave, here amplitude we can keep it as 1, and bias no need to add since we are going to start the graph at a 0 level. And this is the frequency. As we know, the frequency unit is hertz, but the MATLAB will receive radian per second. So in that case, 2 star 2 pi f. 2 pi f denotes that 50 hertz. Right, you can keep other things and all, you can simply keep it as it is. So now we can get a sine waveform, right? We can get a sine waveform. So this is the 50 hertz pulse. So in that 50 hertz, so you should reduce the value. So just I'm reducing the value 1 second. I'm just reducing the value at 1 second. I will show you the simulation parameter graph. I will show you. Please try to engage with the class. Yes, again it has been so just open the scope, change into the 4 signal, change the layout also. Just change the layout also. So now I am just trying to run this simulation. Now I am just trying to run this simulation. Yeah. See here, this is the typical sine waveform. This is the typical sine waveform, but it's not exact sine. We have to increase the mathematical calculation accuracy. We have to increase the mathematical calculation accuracy. How we can increase the accuracy? See here, just open the simulation parameter. Go to the debug mode. Open the parameter. Just a second. See here, just select this button. Just select this button. Here the solver information will be available. So here the solver information will be available. Just select it. Now we are trying to improve the accuracy of the simulation. Okay. So here, so just select the fixed step and just select here. So apply 1 e power minus 6. Just apply e power 1 e power minus 6. Alright, and now you can run this one. So you can get a pure sine waveform. So earlier it was not a pure sine waveform, now it is a pure sine waveform. So by this method we can improve the accuracy. Now by this method you can improve the accuracy of the simulation. Right? I hope you understood. If you have any questions, you please comment. So if you have any questions, you please comment. I will try to give you the answers. If you have any questions, you please comment. I will try to give you the answers. If you have any questions, you can ask me. I will try to give you the answers. Yes. So this is sine wave generation. So now we have to compare this two waveform with another one. So now I am just going to take this, simply just removing this one, and take this graph. Instead of square pulse, I'm going to take a triangular waveform. I will tell you how to generate a triangular waveform. Take a repeating sequence. Take a repeating sequence. So here the repeating sequence. So now we have to generate a triangular waveform like this, right? So we have to generate a triangular waveform like this. So this is the time period, total time period, 0 value, and this is the t, and this interval will be the t by 2. This will be the t by 2, and at this moment x-axis 0, y-axis 0. At this moment x-axis is t by 2, y-axis is 1, and this moment t actually that the full value, that is the full cycle, right? This is the full cycle. So at this moment t is equal to 1, x-axis is 1, y-axis is 0. So like that we have to generate a triangle, repeating sequence pulse. Okay, so now I am just going to take this one. Time value we can keep 0, 0.5, that is 1 by 2, 0.5 and 1. And output value, this is the x-axis 0, 0 and 0.5, 1 and 1, 0. So at the end of the moment, so 0, 0, this is moment, and t by 2 at x-axis t by 2, y-axis 1, this is the second variable, and x-axis is 1 and y-axis is 0, this is the third instant. So now this is the time value, so we have to add the frequency, 1 by frequency, let us take 1000 hertz, in the sense 1 divided by 1000. So the inverse of frequency is the time value, right? So just apply, you will get a triangular waveform. Here you may get a triangular waveform, right? So just to compare these two value. So now one graph will be the sine waveform, one graph will be the triangle waveform, and another graph will be the square function. Yeah, see here. So we can adjust the graph value, just select this graph. Yeah, so this is the sine waveform, this is the triangular waveform, right? And this is the square waveform. So now if you compare these two value, AND gate or OR gate, to take a relational operator. So if you want to compare the values, so just take this relational operator, take sine function and take so first to take a sine function, just to take a sine function, and this is the triangular function. So now you can apply this value, now you can compare. So whenever the sine is high, comparatively triangular with respect to the triangular, then the output should be 1, rest the output should be less, right? So just to take this value. Oh, right, okay, sorry, I will just reconfigure this one. Yeah, just a second, I will just remove the one. Let us take a sine function, first graph, triangular function is the second graph, and the third function is the output graph, PWM generation. So this is the third graph. So now we can analyze that. Yes, see here, we have compared whenever the signal high, whenever the sine waveform is higher than the triangular waveform, then only the output will be high, otherwise the output will be 0, right? So like that we can generate a sine pulse width modulation for the inverter. I will tell you where you can use this PWM in the next forthcoming session. So try to engage with the entire session. So try to engage with the entire session, right? So many people are asking what is YouTube, what is participation, what is internship. So in the YouTube, of course, the class is completely free. You can ask and you can get your query resolved there. Whereas you will get a participant certificate with the help of 25 days attendance, right? And see here, this is the internship. In the internship, you will get an internship certificate, internship completion certificate, and access, you can access all the recorded classes with our mobile app, Android app, and as well as that web app also there, right? And you can download the MATLAB Simulink model from the internship portal. You can download the PPT, you can download the Excel sheet, whatever you want, and we will give you the we can give you the Google Zoom class also. On weekly basis we will give you the Zoom class for the internship users, not for the YouTube users. And I use this coupon code. The last date is on 2nd July. Last date is 2nd July. So till that you can join in this EV design masterclass. Please explain what is the use of this wave in the EV section. In the EV section, we are going to use the electrical motor. That electrical motor is controlled by the PWM method. So for that, you should know what is PWM, how to generate a PWM. So in the forthcoming sessions, we will discuss with this PWM only. With this PWM only. Right? If you have any questions, you can ask me. If you have any questions, you can ask me. I'll try to give you the answers. If you have any questions, you can ask me. I'll try to give you the answers. Do you have any questions? Already PPT day one PPT has been sent, and day two PPT after this live we will try to send. Please explain what is the use. The PWM is the main key factor to control the motor. So in that case, within a day you may not able to get a full point. So try to engage with the entire class. You will get the entire informations. Any more questions? You please ask me. I'll try to give you the answers. Already PPT has been shared, so please check your email. Please check your email, Mr. Famous. Thank you, Shekhar. If you have any questions, you please ask me. Yeah, Mr. Ajit, please check. See the in the EV we are going to use the electrical motor. That electrical motor we are going to control with the help of PWM only. So that's why we are discussing about the EV. If you have any more questions, you please ask me. PWM nothing but pulse width modulation. PWM nothing but pulse width modulation. So if you have any questions, you just take my number and then share your share your query. I will try to give you the answers. Internship is online mode.